So today's topic is dipole-dipole forces. Dipole-dipole forces and dipole-induced dipole forces. So in my last video I have already told you about London dispersion forces in my last video. So here I am going to explain about dipole-dipole forces and dipole-induced dipole. All these are attractive forces. Attractive forces between the interacting particles present in matter. The attractive forces between the interacting particles present in the matter. So in these attractive forces, there is so many attractive forces, but in that van der Waals forces are there, ion dipole forces are there, and hydrogen bonding, and so many are there. So in that van der Waals forces, London dispersion forces are there, dipole-dipole forces are there, and dipole-induced dipole forces also there. So in my last video I have already explained about London dispersion forces, LDF. So here I am going to explain about dipole-dipole forces and dipole-induced dipole forces. So dipole-dipole forces, these are the forces between the molecules possessing permanent dipole. The molecule possesses permanent dipole. We can see the dipole-dipole forces. Right? For example, I am taking HCl. So HCl is polar molecule. That means it possesses positive pole and negative pole. So this Greek letter delta is used for dipoles. Positive, negative, right? So any molecule possessing partial charges, that means positive charge and the negative charge, then this molecule is polar molecule, right? Polar molecule. Why? Because polar molecule having dipoles, that means two poles, positive pole and the negative pole, right? So polar molecule means the molecule, which molecule containing poles, that means positive pole and the negative pole, that means possessing partial charges, then it is a polar molecule, right? So we can see dipole-dipole forces in polar molecules. Why? Because polar molecules having permanent dipole. Two poles are there. In polar molecules, we can see dipole-dipole forces. Here I am taking two polar molecules. So here I am representing lines. Why? Because these lines represents the more electron cloud here. These lines represents the more electron cloud. That means this is polar molecule, right? So more electrons are present here. That's why here negative charge. Right? In this molecule, less electrons are present here and more electrons are present here. So that's why I am representing lines. That means lines means in this place electron cloud is high. Here electron cloud is less here. So Here the attractive forces between the negative pole of polar molecule and the positive pole of another polar molecule is dipole-dipole forces. Dipole-dipole forces. The attractive forces between the dipoles. That's why it is dipole-dipole forces. The attractive forces between the dipoles, the negative pole of one polar molecule and the positive pole of another molecule is dipole-dipole forces. Dipole-dipole forces. So generally the dipole-dipole forces are stronger than LDF. LDF, London dispersion forces. Why? Because dipole-dipole forces appears in molecule possessing permanent dipole. Permanent dipole. Here in LDF forces, London dispersion forces appeared in temporary dipole molecules. Temporary dipole molecules. But dipole-dipole forces appears in molecule possessing the permanent dipole. That's why the dipole-dipole forces are stronger than the LDF, London dispersion forces. Okay, so actually these attractive forces are inversely proportional to. That means attractive forces are inversely proportional to the distance between the dipoles. That means distance between the polar molecules. Why? Because I am saying here. So here attractive force. These attractive forces are inversely proportional, not directionally. Inversely proportional to distance between the dipoles. If the distance is increases, then attractive force is decreases. If the attractive force is increases, then distance between the dipoles, that means distance between the polar molecules, is decreases. The attractive energy is increases, then distance between the polar molecules is decreases. Simple. If the distance is increases, then attractive force is decreases. The negative pole of one polar molecule and the positive pole of another molecule, right? This attractive forces between them depends upon this factor. Distance is high, then attraction is less. If the distance between the polar molecules is high, then attraction is low. Stationary polar molecules. What is stationary polar molecules? Stationary, that means solid state. In solid state, the polar molecules possess this type of attractive forces, 1 by r cube. Attractive force is inversely proportional to 1 by r cube. So r means distance between the polar molecules. R means distance between the polar molecules. So stationary polar molecules, generally dipole-dipole forces appears in polar molecules, right? So stationary polar molecule means in solid state. So rotating polar molecule means in liquid or gas, both. Liquid or gas, both. In these two states, the polar molecules are rotating, not rigid, not stationary. So in these rotating polar molecules, the attractive force is inversely proportional to 1 by r power 6. R power 6. R means the distance between the polar molecules, simply. If the distance is high, then definitely the attractive force, attractive energy is low. If the distance is low, then attractive force is high. Simple. So this is all about dipole forces. Dipole forces. Next one is dipole induced dipole forces. So dipole induced dipole forces. All these are attractive forces. You have to remember, all these are attractive forces, not repulsive forces. So all these attractive forces are present in interacting particles present in the matter. So here dipole induced dipole forces. Here you have to observe dipole and induced dipole. I have already told you in my last video induced dipole. So the forces, these forces between the polar molecule having permanent dipole and molecule having lacking of permanent dipole, that means non-polar. These forces, dipole and induced dipole forces, are between the polar molecule having permanent dipole and the molecule having lacking permanent dipole. Right? So here I am taking example delta positive, delta negative, right? So this is polar molecule having permanent dipole. Di means two poles, positive pole and negative pole, right? This is polar molecule, right? So this is non-polar molecule, right? Non-polar molecule. That means electrons are equally distributed here. So then this polar molecule, this negative pole becomes, this non-polar molecule becomes induced dipole. Why? Because induced dipole are formed here. So this positive pole pulls the electron cloud of this atom. So then this non-polar molecule becomes induced dipole. So that's why here induced dipole are formed here, right? So here then the positive pole of polar molecules induces the non-polar molecule. That's why induced dipole are formed here, right? So here the positive pole of one molecule attracts the negative pole of induced dipole. These forces are dipole induced dipole forces. We have to observe clearly. The positive pole of one polar molecule attracts the negative pole of induced dipole molecule. These attractions between them is dipole and induced dipole forces. Is it clear? So molecules of larger size can be easily polarized. Generally, large size molecule easily polarized. You have to remember, easily polarized. So small size difficult, simply difficult. Why? Because if a molecule having large size, then electron cloud of molecule is easily distorted, then becomes polar molecules. So molecule having larger size is easily polarized and small size is difficult to polarize. Is it clear? Though high polarizability increases the strength of attractive interactions. High polarizability. Polarization is high, then strength of the, if polarization is high, then strength of the attractive forces also high. High polarization happens, then definitely there is strength of attractions is also high. This is all about induced dipole forces. So next one, generally in attractive forces there is so many attractive forces are there. So hydrogen bonding. In my last video I have already told about hydrogen bonding, right? You can check it once. So generally I am saying here simply, hydrogen bonding appears only in some molecules. So what is hydrogen bonding? So in some molecules means the molecule contains hydrogen and also nitrogen, oxygen, fluorine. All these having high electronegativity, right? So if the molecule containing this high electronegativity atom, then we can see the hydrogen bonding. There. There is also simple aspect. There is also, so hydrogen is less electronegativity than fluorine, right? So here high electronegativity, that's why fluorine gets negative charge, hydrogen gets positive charge, right? So this negative pole of one molecule attracts the positive pole of another molecule. This attractive force is hydrogen bonding. So I am explaining here simply, but you can check it once in my another video, hydrogen bonding. Here I am explaining simply. So hydrogen bonding means the negative pole of one molecule attracts the positive pole of another molecule. But hydrogen bonding appears, this attractive force, this bonding appears only some molecule. So the molecule having high electronegativity atoms, then we can see the hydrogen bonding there. Simple. All these are attractive forces between the interacting particles present in the matter. So next one. All these are attractive forces, right? Thank you for watching.